Hello everyone, welcome to the Introduction to the Tree Methods lecture. In this lecture, we will talk about decision tree and random forest as the machine learning models. And if you want the mathematical background of these topics, go ahead and read chapter 8 of this Introduction to Statistical Learning. And the link is given below in this slide. And it's a chapter 8 of this book. And the book is free for download. You can download a copy and referring to the mathematical background. Let's start off with a small experiment and to give some motivation behind what we use for decision tree methods or trees method. Imagine that I play tennis every Saturday, and I always invite a friend come to play with me. Sometimes a friend comes and sometimes not. It depends on a variety of factors, okay, such as weather, temperatures, and humidity, wind, and etc. I started to keep track of these features and whether or not it showed up to play with me. And in my data, it looks of something like this. And in the next slide, okay. So each one of the column represents a feature, and each of the row represents a day. I go ahead and for each day, I write down the temperatures and outlook of the weather and the humidity, and it is windy or not. And then the last column is I recorded whether or not my friend came to play with me in tennis. Okay. So you can see the first day I have a temperature mild, a sunny outlook, humidity 80%, and windy, not windy, and my friend came. And the second day, temperature is hot and sunny outlook, and also humidity is 75%, it is windy. My friend didn't come, okay, to play. In this case, I can use this process to build a decision tree of this process. I want to use this data to predict whether or not my friend is going to show up to play with me in an intuitive way. To do this is through a decision tree. And this is what a decision tree looks like in the next slide. All the data just showed in this tree, okay. We have node and a node split for a value of a certain attribute. And for example, we can see that the top node right now is the outlook. The weather outlook either is sunny, overcast, or is raining. And the second layer, we have the humidity and the windy situation. The humidity is less than 75% or greater than 75%. Windy is just yes or no. Okay. So for each of these attributes are in nodes, and then we have edges. Edges are outcome of the splitting for each one of the nodes. Okay, to the next node. In this tree, we have a so-called root, which is, in our case, is the node that performed the first split. In our case, is the outlook node. And we have the leaves. Leaves is terminal node that are predicting the outcome of the experiment. The intuition behind the split is, imagine a data, hypothetical data. I have three features, X, Y, and Z. With two possible classes, either class A or class B, represents the outcome. Okay. So I ask, okay, which one of these features give me the perfect separation? It's clear you can see that Y actually give us the perfect separation because the Y features actually synchronize with what the classes are. However, X and Y actually are not, X and Z, however, are not giving proper separation in this case. Let's do that. Okay, Split on y give a clear separation between classes if y equals to 1, and the outcome is definitely class A. If y equals to 0, then definitely is class B. So now let's look back, and x and z are not necessarily giving the perfect separation in that case. And in theory, the entropy and information gain are the two mathematical methods that choosing the best split, which features we use to split. For any mathematical background for those, and please refer to the chapter 8 of the An Introduction to Statistical Learning textbook, and they have a clear explanation, and we will discuss a little bit later on in our Jupyter notebook. One can also try to split on the other type of features, and let's talk about this. And so you can see that y actually has a perfect separation, and x and z are not giving a separate proper separation. Next thing we're talking about is random forest. The primary weakness of a decision tree is they don't usually give a very high accuracy in the decision tree, and they tend to not giving the best prediction. This is particularly due to the high variances, meaning that different splitting on the training data can lead to very different trees. The backing is a general purpose procedure for reducing the variances of machine learning method that discussed in chapter 8 of the the textbook. So we can also build off the idea of backing by utilizing random forest method. It is just a slight variance of these backing ought to treat that even better performance, which is what we're going to discuss in coding out what we do in random forest as we created ensemble decision tree using bootstrap sampling of the training set. Bootstrap sampling of the training set just meaning sampling from the training set with a replacement. However, we build each one of a tree each time a split is considered a random sample of m feature out of total p features. Okay, so m feature is a number of features we're going to choose to split in the random forest, and total I have p features. And typically this split, the m is equals to the square root of p. So in this case, usually we just randomly choose m features out of p and giving a decision tree based on those subset of the features. Okay. So what is the point for those? Suppose there is one very strong features in our data set. When using the traditional background tree, most of the tree will start using these strong features and as a top split. And resulting ensemble of similar trees are very highly correlated, which result the variances may not be able to reduce the variances. Averaging highly correlated quantities does not significantly reduce the variances. By randomly leave out the candidate features from each one of the split using in the random forest decorrelated tree, such that the averaging process can significantly reduce the variance of the result model. Okay. With all these theoretical background and introduction of the concept, we will start by take a look at a small example using Python. The small example data set is a kyphosis, is a medical spine condition. Patient and trying to predict whether or not a corrective spine surgery is effective or not. So we kind of using a small example. I give you the link on this place. Then we'll exercise this method using a long data, so-called landing clock long data set to predict if a long is going to be default or not. So let's conclude this lecture, and we'll see you in the next lecture about Python and Jupyter Notebook.